Greetings mathematicians. In this video we're going to look at all of the different adding, subtracting, multiplying polynomials that we've done so far and put everything together into more multi-step problems. But first let's start with a quick warm-up. Go ahead and pause the video, give this problem a try, and then come back after you're done to check your work. Alright, so now that you've had a chance to try that one, remember that when you subtract, your first step is to essentially think of this as a plus -1, distribute the -1, which basically just changes all of these signs, and then combine your like terms. So let's take a look here. Here is our first multi-step problem. And basically what you see here is instead of just multiplying two things together, we're multiplying three things, so three factors. So basically if we didn't have this 2x here, this looks a lot like what we've done in the past where we did a binomial times a trinomial. Now we've just got an additional factor. Basically what you want to do here is multiply these two factors at a time and see what you come up with. So because multiplication is commutative, it doesn't really matter which order you multiply the factors in. I typically just go left to right. That's totally up to you. So I'm going to start by multiplying these two factors together. So I'm going to distribute the 2x first, which gives me 2x cubed plus 8x squared minus 4x. And then I still have the x minus 5 at the end. And then after that, I'm going to distribute the x minus 5 through my trinomial. So after I distribute essentially twice, distribute the x minus 5 through the trinomial in the brackets, and then distribute the x and distribute the -5 and combine all my like terms, then I end up with 2x to the 4th minus 2x cubed minus 4x squared plus 20x. Now again, it doesn't matter which order you multiply them, so you may have decided possibly at the very beginning, maybe you wanted to multiply these two together first and then distribute the 2x later. Maybe you wanted to multiply the 2x by the x minus 5 and then multiply that answer to the trinomial. It doesn't matter which way you do that, because multiplication is commutative, you're going to get the same answer in the end either way. Right, here is another problem that is going to be a multi-step problem. So essentially what we see here is we see one multiplication problem and then we see another multiplication problem, and we see it's separated by subtraction. And that's basically how you're going to treat this. Do your two separate multiplication problems and then go through and combine your like terms. Now be a little bit careful here. Distributing this 2x shouldn't be too much of a problem. But up here, be careful with this negative sign. You want to distribute the negative x, so this is a negative 9x and a negative x squared after you've done that. And now you're looking for some like terms to possibly combine. And we've got two sets of like terms. We have 2x squared minus 1x squared, which is 1x squared, and negative 2x minus 9x, which is minus 11x. Right, and this will be our last problem for this video. Here what we have is we have a missing coefficient. So we've got a binomial times a binomial. So kx minus 7 times 3x plus 2. And usually this k is a number. So it might be like 4x minus 7 or 3x minus 7. And we're not really sure what it is, but we do know that once we've distributed it and we've combined our like terms, we should end up with this. So what we want to do is try to kind of work backwards and try to figure out what number would k have been to make that work out. So what I suggest is you basically just pretend like k is a variable for the time being and multiply these out. Use whatever method you're comfortable with. So use the area model, use the distribution method, whatever you like. So go ahead and try that first. So this time I chose to use the area model. If you used the distribution method, remember that you would end up with these four same terms. Now don't forget, typically, if k had been a number, which is what we're trying to figure out, then these two terms in the middle would have been like terms and we would have been able to combine them. So just kind of keep that in the back of your mind. And what we're trying to do is we're trying to compare this to the answer that we have over here. And what we can see is what's the same, what's different. So we see the minus 14, that's the same. We know that this 3kx squared needs to be equal to the 15x squared. So off to the side, kind of make that like its own little mini problem and try to figure that out. So the coefficient of 15x squared, that's 15. That needs to be the same as 3k. So divide both sides by 3. K should be 5. And then just as like a quick check, in the middle terms here, plug that in and just do a quick double check, and yes, it would simplify to the correct thing. So negative 21x plus 2kx would become 2kx would be 2 times 5x, which would be 10x, and negative 21x plus 10x would be negative 11x. So that works out. So yes, k would be 5. And then that is our last example for this video. We'll see you next time. Bye.